And so far, we have talked about the derivative of sine, cosine, and tangent. What was the derivative of sine?
Cosine.
Cosine. What's the derivative of cosine?
Negative sine.
Negative sine. And the derivative of tangent? Secant squared. Remember, we did that one doing the quotient rule. So I think, was this the next example? Is that where I left off? I don't remember exactly. Okay. So if I want the derivative, we have to do the product rule because I can see this expression has a t in it and this one has a t. So we have two different things, they both have a t multiplied together, so we do our product rule. So product rule is the derivative of the first one. So in that parentheses, what's the derivative of 2 minus 3 cosine t?
Minus 3, wait, no, just 3 sine t.
Yeah. The derivative of 2 is 0. And the derivative of cosine is negative sine. So it turns out to be just a positive 3 sine t times the second plus the first derivative of the second. What's the derivative of e to the t? E to the t. Okay, so here's what we have. At this point, everything has an e to the t, so you could just take it out. And that leaves us with 3 sine t plus 2 minus 3 cosine t. You could also multiply through the e to the t and just put it in front of each term. So either way, factor it out or put it with each term. Let's take a look at another one. Want the equation of the line, tangent to y equals cosine squared x at the point on the graph where x is pi over 4. All right. When you have cosine squared, that means we have cosine x times cosine x. So to do its derivative, we have to do a product rule. So derivative of the first, what's the derivative of cosine? Second one stays the same, plus the first. Derivative of the second one, so it's again the derivative of cosine, which is negative sine. These terms, they're like terms, they're both negative sine x cosine x, so we could add them together and just say negative 2 sine x cosine x. So if I want the equation of a tangent line, we need a point and a slope. I gave you the point, pi over 4. We need the y value of that, right? So to get the y value, you have to think if I put that in for x, what's the cosine of pi over 4? That's the same as saying cosine of 45 degrees. Mm-hmm. If you square that or multiply it by itself, you get 2 over 4 or 1/2. So that's the ordered pair. It didn't give you the y, so we had to plug pi over 4 into the original to get the y. Now we need our slope. That comes from my derivative. If I plug in my pi over 4, the sine of pi over 4, or the sine of 45 degrees, is radical 2 over 2. Cosine of pi over 4, or the cosine of 45 degrees, is also radical 2 over 2. So we get negative 4 over 4, or negative 1. So now we have a point and slope, and we can write the equation of our line. Y equals m times x plus b. intercept is 1/2 plus pi over 4. You could make that a single fraction if you wanted, but I'd rather keep it in terms of pi than get a decimal. So our equation is y equals negative x plus b, so 1/2 plus pi over 4. So something we've done before just looks uglier because we have all of those expressions, our trig functions. All right. Any questions there? The next table, I gave you the derivatives of all the trig functions. We already had the first three: derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. The other three are all from quotient rules. So we could work out any of them that we wanted. For instance, if I wanted to find the derivative of cosecant. I know cosecant is 1 over sine. So for your derivative, you would do quotient rule. Low. D high, what's the derivative of the top?
0.
Minus high. D low, derivative of sine is cosine. Over low. Squared. So the top just turns into a negative cosine. The bottom, sine squared, that's like sine times sine. So if you separate this, you have a negative, you could think of it as like a 1 over sine times a cosine over sine. That was a trick we did a lot back in trig when we were working our identities. 1 over sine is cosecant. Cosine over sine is cotangent. So the derivative of cosecant is negative cosecant cotangent. Secant, you get the same way by doing the or the quotient rule with 1 over cosine. And cotangent, you can get by doing quotient rule, cosine over sine. So all of these come from quotient rule. Notice all of the co's, derivative of cosecant, cosine, and cotangent. What's true about all those derivatives?
They're negatives.
They're negatives. So all of the co's have a negative derivative, the others do not. They're also kind of similar, like tangent and cotangent both turn into something squared. Cosecant and secant both have those two functions multiplied together. So there are some patterns there. You really need to know these. At the very least, you have to know the first two. The other four you could get by doing quotient rule at any point. You just don't want to have to do that on every single problem. So best to know them all, but at the very least, at least know sine and cosine. You can get all the others from that. So let's practice using these. If I wanted the derivative of x tangent x, I try to use lots of the different notations for derivatives so we kind of get used to them. This is a product rule because I have x's in both. I have an x and a tangent x. So derivative of the first times the second plus the first derivative of the second. What's the derivative of tangent?
Secant squared.
So we just get tangent x plus x secant squared x. Unlike polynomials, these derivatives typically get uglier the more that you do. Second one, we did cosine to the third on Friday. Cotangent to the third. You have to think of this as three cotangents multiplied together. And then we do the derivative of one at a time. So first, what is the derivative of cotangent? That's not one I proved, but we certainly could. Looking back, it is negative cosecant squared x, which in this case our variable is t. The other two would stay the same. Plus, and this one, the first and the last one stay the same. The derivative of the middle one, it's a cotangent, derivative of that is still negative cosecant squared. Plus, now the first two would stay the same, the derivative of the last one, so the derivative of cotangent is negative cosecant squared t. All of these are the same in like terms, we could add them together. They're all a negative cosecant squared t, cotangent squared t. So if we add those together, we get negative 3. Cosecant squared t, cotangent squared t. Any questions? Let's do another one together and then I'll have you guys try one. So I have secant of z over the square root of z, or z to the 1/2. So we have to do our quotient rule here. So remember quotient, low, d high. Looking back, derivative of secant is secant tangent. Secant z tangent minus high. D low, derivative of the bottom. So the 1/2 comes down, z, subtract 1 from the power, so negative 1/2. Over low squared. Okay. There are different ways you could write this answer. The main issue is this term right here, because we have that fraction within a fraction. Z of the negative 1/2 will put it on the bottom, so that's like 1 over 2 z to the 1/2. And the bottom, z to the 1/2 squared would just be z. Do we leave fractions within our fractions? So the easiest way to fix it is just to multiply top and bottom by your denominator, which is 2z to the 1/2. So if you do that, if I distribute it to the first one, I get 2z secant of z tangent of z. Minus, in this term, they would cancel, so just give me a secant of z. On the bottom, when I multiply those z's, I add my exponents, so 1 plus 1/2 would be 3/2. So certainly ugly. It's all stuff that we've done, it's just putting it all together into one problem. You know, we've done the quotient rule, we've done derivatives of just a plain trig function. We've simplified fractions and fractions. It's just, this is a problem that has all those pieces in it. Questions? you guys try this one. So we have below 1 plus tangent t, or tangent x, excuse me. D high, what's the derivative of secant? Minus high. D low, what's the derivative of 1 plus tangent x? All over low squared. So you can distribute, we get secant x, tangent x. I take that times tangent, that gives me plus secant x tangent squared x. Minus secant times secant squared gives secant to the third. Over 1 plus tangent x squared. How'd you guys do? Ugly, but did we get it? Okay. I want to do 2 more examples and then we're stopping for today. So an object at the end of a vertical spring is stretched 4 centimeters beyond its rest position and released at time t equals 0. So we have a spring, we pull it down and we let it go. So position is given by this function, s equals 4 cosine t. Find the velocity and the acceleration. And I think I did give you, on the next slide, I put the equation there so you had a little room to work. How do we find velocity? First derivative. Velocity is just our first derivative. So the 4 would stay. What's the derivative of cosine? So it's just like 4 times the negative sine t. So we get negative 4 sine t. Okay, our acceleration. How do we find acceleration? So we do the derivative of this. We have negative 4. What's the derivative of sine? So the acceleration is negative 4 cosine t. Last one. I want the 27th derivative of cosine. Uh-huh. What's the first derivative of cosine? What's the derivative of cosine? Okay. What's the second derivative? The derivative of negative sine? The third derivative. What's the derivative of negative cosine? Because the derivative of cosine is negative. 2 negatives make a positive. Fourth derivative. What's the derivative of sine? And what happened?
Back to cosine.
Yeah, we're back to where we started. So our fifth derivative is going to be the same as our first, and then we're just going to keep repeating these. So, to figure it out, if you take 27, how many times can you divide it by 4 evenly?
6.
So it gives you like 6.75. So it goes 6 times evenly. Or another way to think of it, 27 is the same thing as 4 times 6 plus 3, right? So this, I'm up here, back to where we began, after my 6 even multiples, and then we have 3 left. So first, second, third. So it would turn out to be sine x. So because my remainder is 3, it's just the third one on the list. Does that make sense? All right, I'm stopping here and letting you guys practice this, I actually have a handout for you today.